Hey, what's up everybody? Chris here with another Proto Tech Tip, and today we want to talk about the delicate balance navigating sheet metal design with precision. And for this video, let's shed some light on overly tight tolerances, understanding how they can affect your design during the manufacturing stage, and then talk about how to fix them with SolidWorks. So, let's get into it. So at Protocase and Protospace MFG, we've revolutionized your workflow and simplify your parts sourcing with the world's fastest custom manufacturing, powered by HVMC, high velocity mass customization. We build your custom sheet metal and machine parts and enclosures in 2 to 3 days, offering a full in-house one-stop shop for materials, components, and finishes. Now, the world of sheet metal design is a landscape of bends, flanges, and intricate formed features. At the heart of bringing these designs to life lies the concept of tolerances. Simply put, a tolerance defines the permissible variation in a dimension. Instead of specifying an exact measurement, which can be practically impossible to achieve consistently, we define a range which a part is considered acceptable once manufactured. Now, what happens when we get a little too enthusiastic with our precision? Well, that's when we encounter the realm of overly tight tolerances. These are tolerances that are significantly smaller than what the manufacturing process can consistently and economically achieve. While aiming for perfection is certainly admirable, specifying tolerances that are tighter than necessary can lead to a bunch of problems, including increased manufacturing costs, reduced material options, and even slight deviations outside overly tight tolerances can lead to fit problems during assembly, requiring manual adjustments or even the possibility of faulty parts. Now think about this scenario. Imagine you are designing a sheet metal enclosure with a cover that needs to fit snugly over the base part. We've initially specified very tight tolerances for the mating edges, perhaps out of a desire for a perfect seamless fit. So let's talk about how we can approach this scenario more practically. The key here is that we want to strike a balance, designing part tolerances that are tight enough to ensure functionality and performance, but are also realistic and achievable within the constraints of the chosen manufacturing methods and the materials for the part. The first step before beginning your design is to analyze the requirements of your design to determine which aspects and features are going to be critical to the fit, form, and function of your final product. Now, it is important to not over-tolerance features that are not critical to the function and allow our engineering and design services team to make any required changes to your design to meet our manufacturing tolerances. Now, before jumping into the design phase, our website does feature charts for all of our standard tolerances and materials and components that we stock in-house. We highly suggest that you check those charts out before jumping into SolidWorks, because understanding our capabilities will provide a realistic baseline for your tolerance decisions. SolidWorks and other CAD software offer powerful features that can really help you design realistic tolerances in mind, and even identify potential issues before you send your designs to us for manufacturing. So now let's jump into SolidWorks and take a look at a few features. So in SolidWorks, instead of manually sketching and dimensioning every hole and feature, utilize SolidWorks' Hole Wizard and standard feature tools. These often come with built-in tolerance schemes. For example, when creating a tapped hole using the Hole Wizard, you can select a standard thread size and class. The associated tolerances are usually well established. When adding dimensions, don't just accept the nominal value, use smart dimensions and explore the tolerance options in the Property Manager. You're going to want to select the dimension that you want to tolerance. Now, in the Property Manager, under Tolerance Precision, change the type from none to options like bilateral, which allows equal positive and negative deviation, symmetric, which is similar to bilateral, max-min, directly specify the upper and lower limits, fit, useful for mating parts, allowing you to select standard fit types, for example, clearance fit, interference fit, etc. So now for the demonstration, let's select the edge of the sheet metal cover and the corresponding edge of the enclosure base. Apply a dimension. In the Smart Dimension Property Manager, under Tolerance Precision, choose Symmetric and set a reasonable tolerance based on the part features and what is given in our charts. So one last thing, especially since we're talking about mating two parts together, when defining how your sheet metal parts will fit together in an assembly, please use mate features with offset values. This allows you to explicitly define a desired clearance or maximum distance between the surfaces. It is important to understand the stack tolerances between your mating parts when setting the clearance. Let me show you what I mean. Select the faces that you want to mate. Choose a coincident mate. Expand the mate options and enter a distance or clearance value. So instead of relying on extremely tight dimensional tolerances for a perfect fit between the enclosure and the cover, apply a distance mate between mating faces with a small distance value, for example 0.01 inches. This ensures a consistent gap, accommodating slight variations within the manufacturing tolerances of both parts. So before you finish, make sure that you clearly document all critical tolerances on your drawings. Use geometric dimensioning and tolerancing, GD&T, where appropriate to precisely define allowable variations in size, form, orientation, and location. This leaves no room for ambiguity during manufacturing. So that does bring us to the end of today's tech tip tutorial dealing with tolerances in sheet metal design, especially overly tight ones. So this is an ongoing learning process, but understanding our tolerance guides, leveraging the tools within SolidWorks, and then maintaining clear communication with us when sending in your design, you can move away from the pitfalls of overly tight tolerances and then create designs that are not only functional and aesthetically pleasing, but are also cost-effective and manufacturable. So if you did enjoy this video, please hit like and subscribe so you don't miss out on any future videos. If you do have any questions, please email us at info@protocase.com, or if you are in aerospace and defense, reach us at info@protospacemfg.com. If you are currently working on a design and want to know how much it may cost, just drag and drop your file onto our instant quoter tool found on our website. And until next time, please take care.